My presentation will be just half time because I will be dividing it with my colleague Stefano Gorini. So I will start myself and then he will follow up with some technical more details. Before disaster recovery, I remember when we started building the global file system at CSCS back 3 years ago, we were very happy and excited. We have now a file system that could be shared with a lot of machines. It's based on GPFS and it's doing a lot of stuff for us. We had InfiniBand too. Because when we started the InfiniBand, we started for the storage. When we built the network for the storage, we did not build it for computing, since we have a lot of systems that's based on the Cray, which use the C-Star and Gemini interconnect. So I went once, I remember, to my boss, and I asked him one question. I said, look, we have a huge dependency in the global parallel file system. If I will come to your office and ask you a question, what you will do if we will lose the file system? I mean, just imagine what will happen, what your answer will be, and how you are going to react. And that was, I promise, that was the reason why we started the disaster recovery, because the file system was growing, we were exceeding terabytes, we started talking about petabytes, and we wanted to look for a solution that we wanted to find a way, in case of a failure, whatever it is, if it is RAIDing failure, software corruption, whatever it is, we should be able to recover the file system. So the point I'm going to talk about here with the short time I have, so I'll be talking about some updates on CSS resources, what were our requirements, the file system, very little information about the file system we have, the solution that we built, and some more points concerning issues that we have seen. I will talk generally about these, and Stefano will continue in details. So this is a non-technical map of CSCS systems, and this has been updated multiple of times. We are just keeping it up to date. And I worked in the last 2 days actually updating it, trying to update as much as I can. You can see that our biggest system here, just last year it was half of this capacity. Now we're at 47,000 cores. We've seen an XK6 with some GPU. We have seen iDataPlex cluster. This is an interesting cluster because it was the first one using a 2D torus actually as an interconnect on the system. This is the new library where we have all the storage, all the backup and the archiving system actually, and some other storage system recently has been installed. There are a lot of changes, and if we go back 1 year ago, we can see that this has really changed a lot concerning year ago. So requirements that we had, we're talking about a file system. It's roughly 1 petabyte capacity, 20 million files. This is what we planned. And I checked last week, this number changed again. They are 35 million. So, when we built the system, we checked all kind of data and we came out with statistics. But looks with time, the kind of science and the kind of data is coming out is changing a lot. So these are changing. These were the requirements at that time based on our data. So we had this is the amount that should be handling for one file system. This is the changes, daily changes, and in case of disaster, how we'll just be able to handle, recovering the file system, getting the metadata in a very reasonable time, recovering the first amount of data, certain %, and then the non-critical in 2 to 3 weeks. Now, we will see that from the peak point of view and numbers, how much the capacity, how much every drive could deliver, it's doable, but we come to sustain, we'll find that it will be very difficult. So we'll have also here we have the migration procedure for the backup. Since this system, it was not covering only the archiving for the disaster, this is also a backup system. So this part will be covered also by Stefano. So I will just jump on this system because he will be talking about it. Migration from the SAMFS and other stuff. I don't know if I'm going back to my place. No. Okay, so upgrading the system, so we had the steps that we need to follow. And one of them, it was how we are going to follow up with the future. the migration of the file system, the growing of the data, and here we start talking about 100 millions of files, 3 petabytes of data, and this is growing. And to be honest, we don't have to wait, a couple of years. We can start seeing that because, last year we had implemented a couple of systems, and all of these systems had to be, we had to put them on at the same level of the global parallel file system. So we had more than one, and all of them, they had the same requirements. This file system is very strategic for us. GPFS, the flexibility they gave it to us. This is one of the reasons, picking this file system also helped us a lot for deciding what kind of backup solution or archiving solutions we had to select. And just to give some information about the kind of file system we have, this is one of them. This is a global file system. Recently, we are in a phase of moving data from one place to another, so it's a little bit differs, but this is how, when we started it, this is how we build it. It's based on NetApp LSI solution with IBM, based on IBM hardware collaboration with NetApp and LSI. We have here the backbone network and all these I/O servers, plus nothing special here concerning the Ethernet. These are the kind of hardware, and this is how it is implemented. And these are the file system, the amount. This library recently in the last couple of months, or when this library was installed, it was 5 racks. So it's just maybe the image here growing a lot, and I hope that it had this dimension, but it's not like this. So anyway, the file system is the file system that we have. All this amount of data, number of files is really scary, and also we can see that if you count each file, we are at like 30 megabytes per second, which is, this is big enough for this kind of science. We don't have small files, 1K or 2K. Also, there's a lot of applications delivering that. We try really to help a lot our users for storing a kind of data that we could manage. And the more this will grow, the more will be more problematic, this number. I know different sites that they don't deliver. They don't put a quote on the amount of data. They put a quote on the number of files, which is the most problem became managing hundreds of millions of files. So this is a layout of the disaster recovery solution. We are talking here about the IBM tape library, TS3500. It has 24 drives connected to a fiber channel, and that's also connected to the TSM HSM server. So the solution from the, it's a complete IBM solution, and that, integrating that with GPFS has a huge advantage for us, in listing, getting the metadata there, and bringing it to the TSM. There are a lot of, let's say, still, not all the features are completed there, but we are working on it. We have the number of the TSM agents, 6 of them. 1 of them is for just managing the library, plus the three servers where you just support all kind of failover. At the top here, we have the file system where everything will be coming. So you can see that the IB network is just implemented everywhere. So all kind of data is passing through IB. And for the last couple of years, we were using always the TCP/IP, just looking to use RDMA at a higher level. That will help us a lot from the latency point of view, and some advantage at the bandwidth also, to avoid any misconfiguration at a high level. So as I said before, GPFS as a solution, TSM is our archiving solution for it. System X is based on iDataplex system from IBM. LTO, I talk about the 05, 3SM, TSM server that I've seen before, the storage agent, and the tape drive. These are the number of cards that you can handle here, 5,719, which is giving us roughly 8.58 petabyte uncompressed. I don't know how, to be honest, I don't know how much that will be if we compress this amount of data. So these are, I believe these are interesting points that I kept it here, because if I wanted to calculate the tapes and how much each tape will be delivering to us, 24 tape drive, the tape drive peak performance of it is like 100 megabyte. And such system should be able to deliver to us 2,400 megabyte per second. When we're talking about 1 petabyte of file system, if we could just pick that as a sustained number, it will be great, because that will be, roughly 1 week we'll be able to recover the file system. But it's not like that. And the reason is that there are multiple of reasons. One of them is just, these tapes should be we should replace the tape and put the second tape, and there's a time between changing the tape, and this is a penalty, a huge penalty for us. Until now, we are unable to guarantee that, the project data are located in 1 tape or 2 tapes that we picked for recovering them. And there are a lot of work there done to be able to handle these issues, because the backup comes based on the time and date and the incremental ones, because if it were not backup, I will not touch them. But when it comes to restore, that will take a huge time, taking the tape, getting a couple of files from it, then changing the tape and putting a second one and getting a couple of files of it, and again and again and again. And there's a huge penalty. So we went down from this amount of 2,400 megabyte per second. I can say just we could go more than half, down in performance. And the 2 or 3 weeks, it's good if we could be able to handle where the data are there. And there's a work is going at the level of the project. So critical projects, we have, let's say, there's the TSM and HSM allow us to say, okay, back up this project in a certain location to be able to get it back restored. But that could not be done at all levels, could be done at a certain project that we believe they are critical. GPFS, and this is, as I mentioned before, this is a very strategic solution for us, actually. I've been doing a lot of work with it. It really proved its reliability, its scales for the kind of science we have there. It has a huge flexibility. We are moving it from one system to another. We are just could handle any kind of replacing hardware. I remember, 2.5 years ago, we replaced all the hardware, all the storage behind without interrupting the service. And this is, what's delivering. There are features is coming to the system, and especially in version 3.5, that will solve a lot of problems for us. Snapshots for the metadata on tapes, that could be one way of going, because that will help us a lot in restoring this data. Because at the moment, if you want to replace the metadata, that will take not 2 hours that we were looking for, but will take about days here to recover at the moment. So we started the backup, we finalized the backup, and we are working in restoring. So we hope that will not have interruption at this time, because we know that the restoring will take longer than what expected. But this is in the plan. I'm not here just to help IBM, telling them that they really respected the roadmap, but we are working with them, and so far they did everything we were looking for. Disasters, I mean, whatever the kind of disaster we have, if we limit that to the hardware raiding, whatever, hardware raiding, and when we build the file system, we started with RAID 5. RAID 6 was not there, declustering, whatever the RAID is coming. But at that time, RAID 5, it had some risk in case of failures, in case of rebuilding the systems, bad blocks, whatever. So that takes time, a lot of time, to be able to get back the file system. And this, I believe, is challenging, because it could take a huge time. To avoid that, we usually just put apart the defected RAID and rebuild it without that defected one and get integrated. And that's the goodness of GPFS. It will allow us to integrate all the ones that defected and add it to the system. Rebuilding the file system, as much as the hardware RAID is up and running, that will be just straightforward. Time to restore the metadata. This is we are working at it. This is what will be coming in the new feature of the GPFS with the snapshots of the metadata. I hope that will be, will be able to do what we are looking for, but we're working on it. I mentioned before the critical project and highest priority. and finally restoring all the kind of data. That will take time. So we mentioned at the beginning 2 to 3 weeks. I believe that could be longer, depends on the number of drives that we have. But our system we could expand that, and in case we need more, but there's always, what we calculate is the timing between changing drives, timing to be able to restore from every project. So that really has a huge impact on the results. So if we want to optimize it for performance, actually, the way we back up, we really need to change that, and that could answer what we're looking for, but we'll be losing a lot of huge amount of tapes that we talked about, and the rest of these points, like grouping them and using some of the new features in ggpfs, I will keep everything for Stefano, and that's my last part. Since time is, I hope that I respected the time. If you have any question?